Okay, so we're going to evaluate limits again today, but we're going to use some properties. We're going to use some algebra, and honestly, it's going to be a lot quicker and simpler, I think, than looking off a graph, though you do need to know that skill. So first, we're going to go through some properties of limits, and then I'm going to make it super simple. So let's get through this. So the limit as x approaches some number, c, if it's a constant function, which would be a number as well, then that answer is just whatever that constant number is. The limit as x approaches some number c, if it's just an identity function, a linear function, then when you plug it in, the answer would just be whatever that number is that you're approaching, because you just do that. And then listed below, that you don't have to write in, are different properties of limits. Scalar just means that if you're multiplying something, then that multiplying could be on the outside. If you're adding or subtracting, you can split it up into multiple limit questions, adding or subtracting. If you're multiplying, you can separate it into two limits, multiplying. If you're dividing, then you can separate it into two limits, dividing. Sometimes as we get into different theorems, that in calculus, knowing these properties will come in more than evaluating right now. The power function, if you have a function to a power, you can do the limit and then to the power. Same thing with root, which is really just a power, just a fractional root exponent. So what does this all mean? It means that a property, it means that to find a limit, it is simply a substitution question. So let's look at number one. I want to know what the limit is as x approaches -2 of this. So simply put, you substitute in -2, answer it, and the answer is 1. That's what the y-coordinate is as x is approaching -2. If I look here, substitute in, and simplify. That's 25, take away 3. Beautiful answer. Is 25 take away 3? That's definitely 22. Got it. Substitution. So at its most basic, a limit is a substitution question. And the question is, when you substitute in, sometimes you don't get the answer that you need. It could be, and we'll look at that at the next lesson. But right now, this lesson is understanding, hey, I want to find the limit of something. Step one is substitution and find the y-coordinate that it's approaching. So that's -1. This is +1, but -4. So it's -1, take away 4, take away 7. So this answer is -12. Again, a substitution. So that's 1/2, take away 4 to the 4. So that's -255.5. Here's the good news, that this answer on an AP exam is done. You don't ever have to simplify in an AP exam to make it look more simplified for a final answer. So many times in our work, we're going to go, you know what, that is good enough. You try to do more work and that you could make a mistake, and then suddenly you would take a point away. But we're going to learn that. Number 5, direct substitution. And then get your answer. Remember that when we're doing a limit, it's the y-coordinate that it's approaching. And what it's equal to and what it's approaching in these examples are exactly the same thing. But there are times that when you're approaching something, that when you're equal to it, it's a different number or it doesn't exist. But the limit still exists, because what it cares about is what y-coordinate it is approaching. All right, that is a great answer. If you feel like simplifying that, the answer would be what? -811. Not necessary. Last one there. Substitution question. So what is it approaching? Knowing that a limit at its most basic is a substitution question. That is square root of 48, take away 3. And that's a great answer. All right, direct substitution. Well, that's what we're doing right now. So the other part was technically using properties but I simplified it and say, hey, if you're going to find the limit, simply substitute in. So determine whether the limit can be evaluated by direct substitution. So I want you to look here. If, and here, let's read about it. Continuous means that there's no breaks, no jumps, no asymptotes. So polynomials are continuous. And to be well behaved because the limit of these functions at any point can be found by direct substitution. That means the value of a function and what it's approaching are the same. That is a definition of continuity. So the limit as x approaches c of f at x, if that equals the substitution, if they're equal to each other, then that means there it is continuous. They're not always equal to each other, and that would mean that they're not continuous then. But if the limit equals the function value, then it is continuous. If something is not continuous, then either the limit does not exist, or we have to find it a different way algebraically. All right, this is a polynomial. All the exponents are whole positive numbers. Polynomial. No fractional exponents, no negative exponents, no fractions, no radicals, none of that. Simple polynomial. Substitution. So, and then no need to simplify, but if you chose to, the answer would be 19. 8. The limit as x approaches 1. Well, if I do a direct substitution, what happens? So 1 plus 5 is 6, and then 1 take away 1 is 0. Now, I don't want you to get into this habit. The AP exam does not want you to write down 6 divided by 0. Instead, we're going to say that this function does not exist. And the reason it doesn't exist, because at x equals 1, what happens? Why? Because there's an asymptote there. That means it's not continuous at 1. That's what continuous looks like in my head. All right, number 9. Direct substitution. Yes, you can. So half of 10 is 5. By the way, that's a great answer. You can leave it. But if you want to go 16, take away 5, beautiful too. 10. Substitute in. And I want you to know this, that we can write this as two limits, and the AP exam would like it much better. So if I write it as the top limit, what does that equal? And the answer is negative 15 plus 4, which is negative 11. If I write it as a denominator as a limit, x squared plus 7x plus 10, if I plug in negative 5, you get the answer 0. So what's happening then is that when you do a substitution, it's undefined. So this limit does not exist. It is not continuous at x equals negative 5. So that you know why it doesn't exist. It's not continuous at x equals negative 5, and it has a vertical asymptote. It could be not exist with a hole, and then with a hole, the limit might still exist, but not with a vertical asymptote. Number 11, substitute in. So what happens? And I want you to notice, just look at the denominator. So if I look at the numerator, well, that's fine. You just plug in and the answer is 3. If I look at the denominator and I plug in 3, you can see the answer is 0. So this does not exist. I'm not going to go and justify it every single time, but you know that the denominator is 0. We're going to look at situations where the numerator and denominator is 0. That is a situation where there's a hole, and then the limit could exist or could not exist, but we have more work to do to know if it exists or not. But as soon as the numerator is not 0 and the denominator is 0, we know right away the limit does not exist. Mean girls. 12. The limit is x approaches pi of cosine squared x plus 2. Does this exist? Yes. Cosine and sine are continuous functions. They're just a wave that goes forever with no breaks, no jumps, no asymptotes. So the limit exists all through the curve. And I'm going to tell you something, that on an AP exam, you don't have to simplify that. So cosine squared pi plus 2 gives you full credit, that you don't have to show off that you know the unit circle. There are questions where that might be in the middle of the question, and you'd have to then be able to simplify it to get to the end. I'm just going to do it for you. Pi on the unit circle is on the left-hand side, and cosine goes with the x-coordinate. This is really negative 1 squared plus 2, and that's equal to positive 1, knowing your unit circle. No, negative 1 squared plus 2 is 3. There we go. 13, trigonometry. Again, I'm just going to ask you to understand what's happening when you plug in 0. So when I do a substitution, the only thing we need to be aware of on the unit circle is there an asymptote there? So cosecant, the graph, are parabolas with asymptotes in between them. One folds up, one folds down. That's why we need to know those trig functions from Math 3 or Compacted Math Year 2. And so at this angle is that one. Well, this goes with cosecant, goes with sine. And if I think of the unit circle pi over 2 up here, sine goes with the y-coordinate. It's positive 1. So the reciprocal exists. For cosecant at 0, when you do the reciprocal, is where it's undefined. So in other words, that is a great answer. It is not an asymptote. Here, this does not exist. So why? So it doesn't exist because when you substitute in, that x value is imaginary. So negative 5 plus 4, you can't find the limit of an imaginary number in this case. So negative 5 plus 4, that's negative 1, and the square root of negative 1. There's not even a graph at negative 5. It would be empty. When we're finding limits, we're finding it of real numbers. So there is no real number when you plug in negative 5, so therefore it does not exist. Trig question again. So back here for secant, when I plug in pi over 2, where is it on my unit circle? Well, secant goes with cosine. The x-coordinate up there is 0. So the reciprocal of 0 gives me an asymptote. And at an asymptote, it does not exist. So this limit doesn't exist because at pi over 2, when you plug in, there's an asymptote. If there's a hole, it could exist. An asymptote, never. 16. So we're going to separate this into 2. So the limit as x approaches 2 for the numerator, that answer is 6. The limit as x approaches 2 for the denominator, that answer is negative 24. This does exist. So now I can go back here. I have no desire to simplify. 6 divided by negative 24, and that's your complete answer with full credit. All right, that's the lesson on direct substitution algebra, not using graph, not using a table. So a lot simpler, a lot quicker in terms of doing that. So the next one will be the homework, extra practice doing the lesson that we just did.